well, welcome to the business end of your first lab, and this is the first time that you're going to use your breadboard that you should have purchased, and I should talk to you a little bit about the breadboard and how it's intended to be used. We went over the connections in the PowerPoint portion of this lab, but just to remind you that buses are connected left to right as you're looking here. There's two on the top and two on the bottom in between the blue and red line. And then in this area in the middle, there's 5 connections vertically and then a space and then 5 more connections. And this is really set up so you can put a dual inline package integrated circuit in here and have the legs go on either side. And we'll be doing that later, but for now we're just going to be using resistors in this lab. And I just want to remind you of how these are connected. When you get this, it's going to require some assembly, and I thought it'd be smart to go over that. I've already assembled mine. You can see there's these 5 stick-on feet that go on the bottom. I just put one on each corner and one in the middle to give it a lot of support. And then these banana connectors require assembly too. And what I found out is that if you put these small plastic pieces that have a sort of a D shape on them in the hole, these end up being loose. So what I did is I turned mine over so the flat part was against the black board, and then put the nut on top of that, and that way they're tight. The other thing you should know is eventually you'll be putting power cables from your power supply in here, but these are not connected internally to your board. So what you're going to end up doing when you want to use power to your board is there's a hole. I don't know if you can see that or not, but there's a hole underneath each one of these, and you're going to have to put a wire in there and then tighten it down, and then run the wire over to whatever bus you want to use for that power supply. For this lab, we're not going to use these at all. We're going to hook power directly to the components with mini clips. But I also want to say something about the wire set you get. The wire set comes in increments, one space increments. And what most people like to do is bend these all up, and they don't last very long if you do that. The system is intended to keep these flat and just use more than one of them to make a connection, so you don't have to bend them. They're yours to bend up if you want to, but it's much more useful if you keep these flat and don't bend them. That way you'll have them to reuse. And it might be a little bit easier if you had tweezers or needle nose pliers to put these in and out. I'm not really sure what's going to be available in the lab in that regard yet, but once you get up to the larger ones, they go in 10 space increments. So you should have all of these, a few of all of these in your set, and I just wanted to show you how they work in there. So with that, we'll go ahead and put together our first circuit. The goal of this lab is to really get you comfortable using the digital multimeter, particularly in the resistor setting, and to introduce you to resistors and your breadboard. So the topic of this lab is resistor networks, as we already said. And your first circuit is somewhat pedestrian, but it'll help you get used to making the measurements. And we're just going to combine 2 resistors in series and measure the value, okay? So what I do with my resistors is I bend the legs at a right angle, and then if you put them on the board left to right in this area, you know they're not connected, because that area, the shorts are vertical. So that's one resistor. And then to connect the resistors, you have to have the middle of this circuit have a common column. So you can see those 2 are connected. So this is not connected, these 2 are connected, and that's not connected to anything. So that's how you should put them in the board. And now we're going to go over how you measure resistance again. Okay, so the first thing you have to do is hit the gray button to turn on the meter. And I already have mine in the ohm setting. If you put this in the ohm symbol, you're ready to measure resistance. And for just about everything we're going to use this for, I recommend using the mini grabbers or easy clips. And the black one always goes in common. So these are banana to easy clip or mini grabber connectors. And then for voltage and also resistance, the red cable goes in the V-ohms-diode symbol. Okay, so this is this is the setup for measuring resistance and voltages. Okay, now for resistance, it really doesn't matter which clip goes where. When you start measuring voltages, the black clip is always going to go to the lower potential, which will usually be ground. But let's just make sure that we got the right resistors here. So I'm going to clip on one end of the resistor and then in the middle. And you can see this measures just a little bit less than 1 kilo ohm on the meter. And then if I move my clip to the other end of the other resistor, I have just a little bit less than 2 kilo ohms. So the circuit's the 1K and the 2K, and then to measure them in series, you just go from one end of the circuit to the other, and it should be pretty close to 3K. So that seems pretty pedestrian, but this just gives you an idea of the kind of measurements you're going to make in the other circuits. So basically you've proved that resistors add in series. Okay, this would be called a series circuit. Okay, so we'll move to our next circuit. All right, for our second circuit, we're going to measure two resistors in parallel, but we're also going to measure the current in each leg and the current overall. So what I've done is I've taken two jumpers that are the same length and I've put them directly across from each other on either side of the gap. Okay, and I'm going to put my one resistor across the gap, lining up with those, and my second resistor on the other end. So on this side of the gap, everything's connected, and on this side of the gap, everything's connected. Okay, so those are in parallel right now. And if you want to measure the resistance in parallel, it really doesn't matter what you connect to, because everything's connected on either side of the gap. So you can connect to that one, and that should give you what the resistance is in parallel. But now what we're going to do is actually apply some voltage to this. I want you to apply 12 volts to the top side and ground to the bottom side. So we're going to measure the current through both resistors and then measure the current individually flowing through each of the resistors. So we're going to set up our power supply. If you remember from the pre-lab, these come up disabled, and we're going to use 1/2 of the dual supply. So we want to set up for plus 12 volts. So hit the plus 25 volt button. Let's turn it on first. And the screen's highlighted, and it looks like it's already set up for 12 volts, but I'll kind of go through it. If you just hit 12 and then OK, it should come up 12 right here. If it doesn't, make sure that you're on the volt setting down here. Hit the blue button there, but it comes up in that by default. So now if you take some banana to easy clip cables and hook to the plus output with the gold background, and again the ground always goes to the black connector. Okay, so if we wanted to put 12 volts across these resistors, we just put ground on one side and plus 12 volts on the other side. And you can see over here that we're drawing a certain amount of current. We're going to want to measure that a little more accurately with the digital multimeter. And to do that, I think I mentioned in the pre-lab that you really have to open the circuit. In other words, you have to put the meter in series with what you want to measure. So we're going to go through how to do that. Measuring current always seems awkward at first because there's a lot that you have to do to really get the job done, and it really isn't intuitive. Because the meter is in series. First thing I want you to do is go ahead and just turn your power supply output off, and the light went off there so you can see that it's off. And unplug your meter, and remember we have to go to a current setting on the meter before we can open these shutters. So I'm going to set this up on the milliamp setting, okay? And then I can open the shutters on the side for the other connectors. You can see these are now open. And I want you to take a banana to banana, a red banana to banana, and we're going to measure the current that's coming out of the power supply and flowing into this circuit. So disconnect your red easy clip from the power supply, and you connect the banana to this power supply, and then we got to go through the meter, okay? So we're going to go in the milliamp connector over on the meter, and then it's got to flow out of the meter into the circuit. So we're going to stick the other red connector that goes to the mini clip that goes over to the circuit in the common. And that's kind of non-intuitive because we've always talked about putting the black lead on the common, but since we're flowing through the meter, it doesn't make any difference. So the current's going to come out of the power supply, through the meter, through the circuit, and then through the ground back to the power supply, okay? So now if you go ahead and turn your supply on, you should get a reading on the meter that corresponds to the current through both legs of these resistors, okay? And we'll leave this set up for current. We're going to measure the current through each resistor now, okay? So we're going to unplug, we'll turn off our power supply again, and we'll put the mini grabber to banana back in the power supply. So now it's going through we're going through both resistors with our supply again. But now we want to measure the current in one resistor. So we're still going to go through the meter. So I'm going to put my red lead in the milliamp and my black lead in the common. But we need to open the circuit, right? So I'll put the black lead, we'll pull the resistor leg up and put the black lead on it. And then this is also going to be awkward. You need to connect back to this point right here where we open the circuit. But I'll draw to your attention that that's connected to the top of the other resistor, right? So if I just clip this red lead over here, then the 12 volts is there. The 12 volts is going to go through the meter into the resistor and through ground. So we're really just measuring the current in the left leg of the circuit, okay? So now if you turn on your supply, you should get a reading for the left leg of the circuit, and I'll let you figure out which resistor has which current in it. So we'll turn that back off and put the resistor back where it was, and then I'm going to switch the 12 volts and the high side of the current meter over to this other resistor, and then pick the leg of this resistor up and put the meter on there, and then that, when you turn on your supply, that'll tell you the current that's flowing through the other resistor. Alright, this is the voltage divider circuit, and I've configured it to look kind of like the schematic in the PowerPoint presentation, and I would encourage you to do that as much as possible. This is the series resistor, and this is the shunt resistor that goes to ground. And we're going to hook the 12 volt supply up to that resistor right there. That's just where it's shown in the schematic, and then the output is where these are joined together, and then the ground is going to go to the bottom of the shunt resistor right like that. Okay, so what we want to do is we want to measure the output of this and make sure it matches the calculation for voltage divider that you're going to perform for these two resistors. Now if you remember, the last time we used our meter, it was set up to measure current, so we got to put it back to the way it needs to be to measure voltage. And remember, you can't close your shutters until, first of all, you remove your wire, and then you have to close them before you can move off of these milliamp settings. It won't let you move if the shutters are open. So now you want to go back down to the voltage, DC voltage setting, okay, with a line on it. And by the way, it also gives you a line up here. In some of these settings, you can hit select and toggle between AC and DC. If you have a little squiggle up here, you're in the AC setting, so make sure that you have the line up here. That's not an issue for the voltage because you have a separate setting on the dial for AC, but that will come up in the milliamp setting. So now we plug this banana to easy clip back in the voltage input over here, and our black is in common. So all of the grounds are usually tied together, so I'm going to put this black common lead down here on ground, okay? And then to make the measurement, you're just going to hook up to the output of this voltage divider, and I'll sort of leave this as an exercise to you. I kind of realized in the first couple of circuits I'm giving you all the answers here. So go ahead and hook this up to the common between these two and take your voltage reading off of the meter and see if that agrees with your calculated value. So now we're going to take what we've learned so far and apply it to a resistor network that has loops in it. We're going to take some current measurements and some resistance measurements and voltage measurements. So let's move on to that circuit. Here's our resistor network. I've gone ahead and built it, and this is probably one example where it isn't going to be exactly like the schematic drawing. So I'm going to go through the way I did it. It doesn't mean you have to do it this way. It may be easier to follow if you do build it this way, but I've used the top bus for 12 volts and the bottom bus here for ground, okay? So this resistor right here is the 1K resistor on the input, and it's going from 12 volts to 3 places actually. It's going to the 2 parallel resistors. I use the orange wires here to put these in parallel across the gap, and then the 1K is connected to the left resistor here. And I've also taken another wire out to the resistor that's in parallel to the parallel combination, which is another 4.99 k ohm resistor. And then these parallel resistors here come down and they're joined together by this orange one, and then they go through a 2K resistor and then through the 150 ohm resistor to ground. So this is the 150 ohm resistor to ground. And if you look at the schematic, this 4.99 resistor on the right side is going from the top, in other words the inside of this 1K resistor, down to the 150 ohm resistor as well. So this is how I've configured what's on the schematic, and you're asked to take some current measurements and some voltage measurements here. So the first thing you need to do is power it, and if your supply is still set up with 12 volts and ground, you can just connect the 12 volt up to your resistor that's in that bus, and the ground up to the resistor that's in that bus. Okay, and I would recommend taking the voltage measurements first. So if we turn on our supply, we're already set up for voltage measurements. You'll want to put the black clip of the meter on ground down here, and then you're asked to take a voltage measurement at two places, and one of them is referred to as node 1, and that's the bottom of these two parallel resistors here. So you can hook onto either one of these legs, and you should get the voltage value at node 1. Well, you will get the voltage value at node 1. And then the other place to take the measurement is node 2, and that's on the other side of the 2K ohm resistor, where the 2K ohm, the 4.9K ohm, and the 150K ohm all come together. So anywhere in here is node 2. You can take your voltage measurement there. Okay, and I think that's it for voltage. So we need to change back over and take our current measurements. Okay. You're also asked to measure the voltage across each of these resistors, and this is an alternate way to calculate the current. You can measure the voltage across the resistor, divide by the resistor value, and come up with your current according to Ohm's law. So the way you do that is, depending on where you put your black lead, you're going to get a positive or negative voltage. Just take the absolute value of whatever voltage value you have if you get a negative one. If you're careful and you put the black lead on the lower potential of each of these, which may or may not be obvious from the schematic, you should get a positive voltage. So I'll start with what we call R7 in the schematic, and you can see I've just gone from one side to the other, and I've tried to go to the lower potential, and your meter should be reading the voltage across there. Now these next two resistors, because they're in parallel, they're going to have the same voltage across them. So for each of these resistors, R8 and 9, you can just make one measurement. So since they're in parallel, you can put the red lead on the top of them and put the black lead on the bottom, and the voltage will be the same for each of these two resistors in here. Okay, and you just continue for the other three resistors the same way. You'll, on this outside resistor, you'll put the red lead here, and the black lead goes down here. Okay, for this 2K resistor down here, you'll put the red lead there. You'll put the black lead on any of these resistors here because they're all joined together. And then for your last resistor, you can put the black lead on ground and then the red lead over here. So you end up just stepping through the circuit with your voltmeter to measure the voltages across there and fill in the table at the end of the lab. Okay, so now we're ready to measure the current through each one of these, and we'll get set up to do that. So we'll need to configure our meter for current again, and we'll go ahead and put this in the milliamp setting and open the shutter and move our red lead over to the milliamp, so it should look just like that. Okay. Now remember that we're going to have to measure everything in series if we want current, so everything's got to flow through the meter. So if you turn off your supply, the first resistor that you have to measure is the 1K resistor, and you'll put the input of your meter, which is now red, on that end of the resistor. And I'll get my hands out of the way here in a second. And then you'll put the output of the meter back where the resistor used to go. So that right there, if we turn on the supply, would give you the current through R7, or your 1K resistor. All right? Okay. Now if we put that back, make sure you get it back where it was, otherwise things are going to get dicey. We also need to measure the current through the other resistors. So let's start with the one on the outside of the parallel. So I lift that leg up, okay, and I'm going to hook that to the outside of the output of the meter, and I need to put the other side where that used to go, and it was connected in parallel with that resistor, so you could measure the current through that resistor that way, and that would be R9, okay. So let me put that one back. And I lift up the leg on R8, put the black lead on there and the red lead on the parallel connection, and that's how you would measure the current for R9. So I think you should get the idea by now. You need to pick up each leg, you put the input where the resistor used to be connected, and then you put the output on the resistor end that's open or up in the air. And if you can just measure all of the currents that way and record them in the table. This circuit should be very similar to what you're discussing in the lecture. There's meshes and a number of loops in this circuit that you actually measured the current loop for when you measured the resistors currents. There's a loop between the parallel resistors over here. There's another loop between the two parallel resistors and through this 2K resistor and up through this 4.99K resistor. And then there's an outside loop that goes through everything, for the 1K and the parallel resistors and the 2K and then the 150 ohm resistor that also includes your 12 volt power supply. And you can look at the loop currents and see if that agrees with what you're learning in the lectures, and it might help you understand how the loop currents add or subtract, as the case may be. And we've also learned to measure currents, DC voltages, and resistances, so you should be fairly comfortable with this digital multimeter. In the next lab, we'll start talking about AC response and throw some capacitors in the circuit and start using the oscilloscope to look at some AC signals.